This is from our packet that you got the other day. This is the Chapter 8 practice exercises, free response number 2. And I said that this was a tricky problem. I was misremembering. I apologize. This problem, if you draw two free body diagrams, is relatively straightforward. I was remembering something that you will get on a future free response test that some of this plays into, but it's much more challenging. All right, so the issue is we're trying to figure out if this crown, okay, is made of gold or not. And in the problem, they give us the ratio of gold to water. So I'm going to write that up here at the top. The ratio of gold to water is 19.32. So what do I need to figure out? I need to figure out the density of my crown. I'm going to use a C for that, compared to water, and see what it equals. If it's more than 19.32, unlikely. It's something denser than gold. Odds are, if they have a fake, it'll be less dense. But if I get anything other than about 19, it's not gold, okay, or at least it's not pure gold. Let's take a look at our setup here. Some information was given. We have the crown hanging from a spring scale, and I've drawn a free body diagram. Force the scale up, force the weight down, and they said that the scale reads 25.14 newtons when it's suspended from a spring scale in a normal fashion. If I sum forces here in the y direction, you wouldn't really have to show all of this. It would be 0. So scale minus weight equals 0, or force of scale equals force of the weight. This backs up my claim that my weight is also 25.14 newtons, and I can put a sign on that. Yeah, it would be negative. If I want to have the direction there on the number, or the magnitude is 25.14 newtons, that would be okay as well. Scribble that out because I've got my direction right here. So that's all pretty straightforward stuff. Now we put the crown in water, and it says that this time we get a reading on the scale of 20.65 newtons. So this is 20.65 newtons. And we know the weight hasn't changed because this is still m times 9.8, so 25.14 newtons. From this, I can get the buoyant force. That'll come into play in a minute, but I'm really looking for the density of the crown. And for the density of the crown, I need the mass of the crown over the volume of the crown. The mass is pretty straightforward. Since we have the weight is 25.14. Let's see if I can type. 25.14. We divide that by 9.8, and I get a weight of about 2.57 kilograms, or excuse me, a mass of about 2.57 kilograms. Mass, because we're in kilograms. The weight was the 25.14. So now all we need to do to figure out if this is gold or not is get the volume of the crown. Well, good news for us. The crown is submerged in water, and we have enough information to get to the buoyant force. What is buoyant force? The density of water, or the liquid that we're in, which in this case it's water, times the volume of the fluid displaced. What's the fluid's displaced volume? It's the volume of the crown, because it's completely in the water. So I'm going to put VC, and I'm making an assumption here that the crown would sink in water, that it's not a crown made of styrofoam. If it was a crown made of styrofoam, you'd pick it up, and right away you would know it wasn't gold, right? There'd be no chance of someone believing that claim. So volume of the crown times G. I'm going to solve. I'm going to sum my forces and solve for volume of the crown. So sum force in the y direction equals 0, because again, it's just sitting here. It's not moving around, just like this one as it was up above. And we've got three things. Scale, buoyant force minus weight equals 0. Our scale is 20.65 newtons. Our buoyant force is what we're looking for. I'm going to go ahead and put the rho VG in there. So plus 1,000 is the density of water, times the volume of the crown, times 9.8 meters per second squared, minus the weight, which is 25.14, equals 0. And now I've got one equation, one unknown. I can solve this for the volume of the crown. I'm going to leave out the algebra here. 25.14 added to both sides. Subtract 20.65. Divide by 1,009.8. And I'm getting, oh, I did something wrong. Oh, I multiplied by 1,000. 4.49 divided by 1,000. divided by 9.8. That seems relatively small. That seems more reasonable. 4.58 times 10 to the negative fourth meters cubed. Originally, I got a volume of the crown of 458 meters cubed, and I knew that would be off just a little bit. So now I'll go back here and get my density of the crown. So 2.57 divided by the volume. And let's see what we get there. 2.57 divided by 4.58. Negative fourth. And we get 5611 kilograms per meter cubed. Go back up here, now I have the density of the crown and get my ratio. So density of the crown is 5611 kilograms per meter cubed divided by 1,000, which is the density of water, fresh water. Take my answer from here and divide by 1,000, and I get that this is 5.6. So my ratio of gold to water is 19.32. It was given in the problem. I did a lot of work to get to, or a little bit of work to get to the density of the crown so that I could do the ratio and find out that 5.6 is less than the ratio of density of gold to water. So this is less dense, and therefore it is not real gold. And is this someone trying to sell you something probably? Well, if they're trying to sell you, don't buy it. Okay, yeah, vendor. Someone's trying to sell you something. Don't buy this. It's not real gold. That's it.